Hi everyone, in this lesson today we're talking about lesson 4.3, which is domain and range. The most important thing to know about domain and range is domain is all of the x values and range is all of the y values. That is the most important thing, and you can kind of remember it because they're in alphabetical order. Like domain is the smaller in the alphabet, and x, like domain D comes before R and x comes before y. That's kind of how I remember it. So determine if each of the following is a function, and then state the domain and range. We have talked about functions before, do you remember? So let's look at these and try to decide whether or not they're functions. Remember the definition of a function. So if every x has only one y, then we need to look at our x values. And so I'm going to highlight these x values so we pay our attention there. And we're looking to see if anything repeats. And actually it does, doesn't it? This one and this one both have a 2, but they have a different y value. So this one is not a function. Okay, we're going to list the domain, and I didn't draw that very well. It's kind of hard for me to draw them. They look like this, and so maybe I could redo that one. That's a little bit better. When I list my domain, I want to go in order as much as possible. So the lowest number is -4, and the next lowest, -1, and then we have a 1, and then we have 2 2s, but we only need to list it one time, because that's just the same number. We don't have to repeat it when we write it down. And then the range, so remember the domain is your x values, the range is your y values. So the range are the y values. And again, I want to go from the lowest to the highest. Looks like my lowest one is -3, and then -1, 0, and 2. So that is our range. We're going to do that same thing on each of these functions or relations and decide if it is a function. So we're going to look at the x's and see if any of them repeat. They don't. All of the y's repeat, which is, again, a little bonus information for you. You don't have to know this, but this is going to be a constant function. Remember we talked about that last lesson? If all of the y's are exactly the same, it's going to be constant. But it is a function. And the domain, again, we want to list all of them. We want to start with the lowest number and go up to the highest. So look like 1, 2, 3, 4, 5. And the range, we only have one number in the range, and that's -5. And again, that's because it's a constant function. All right, we're doing the same thing. We're just focusing, again, deciding if it's a function or not. So if we look at our x values, we look to see if there's any repeaters. There are not any repeaters, so this is a function. The domain is all of our x values. The range is all of our y values. I like to start at the lowest and go to the highest. The range, same thing. It is the y value, so they're already in order. We just have to put them on the line. All right, this next one, they're trying to kind of throw you off, but we can't be fooled. This is an x column. This is the y column. So again, we're looking for, are there any that repeat? And there are not, so this is a function. And we will list the domain or the x's, the range or the y's. Okay, last two. Remember we have these things called mapping diagrams, and what we're looking for is this little V. And if it has a V like that, remember the definition, every x has only one y. This x has 2 different y's, so this is not a function. All right, so again, domain is the x values, range is the y values. We put them in order. Okay, let's look at the next one. Here we have that pointy. Remember we already said if there's that point, then it's not a function. But this one is going the other way. So that's okay. You can have that type of point going on, but not this kind. Because, again, does every x have a different y? And yes, every x has a different y. And so that one is a function. We're going to list our domain. It's the x's, and our range is the y's. So we put our x's here on the domain, y's here on the range. Let's turn the page. Okay, when you look at a graph, remember I said a minute ago that the function, the idea of a function is that every x has only one y. The other thing about a function is it passes the vertical line test. Do you remember we talked about that? That's where if I take this vertical line and I pass through the function, is there anywhere that it is going through more than one at a time? Here. So this is not a function because it does not pass the vertical line test. All right, let's come to the next one. Is this a function? It is a function because there's nowhere that it hits more than one time at a time, right? More than one dot at a time. They're all individual, separate. So this one is a function. Okay, let's look at the domain and range a little bit more closely because now it's on a graph, which is different than a list. So again, the domain is still my x's. So I look at the x's. There's a -2, -1, 0, 1, 2, and 3. And then I look at my y's. I always want to start with the lowest and go to the highest. So down at the lowest starts at -3. I messed that up. I need to put a -3 in there. Okay, I also messed up on the other end. So if you wrote that down already, change it because I fixed it. It starts at -3, -2, -1, 0, 1, 2. So our range is our y values, our domain is our x values. Okay, let's look at the next one. Does it pass the vertical line test? No, it does not. It's hitting more than one place most of the time. So no, it is not a function. Since it's not a function, we really oftentimes don't answer these, but let's just go ahead and talk about it because so far we've had these points as like separate numbers. Here we would not have separate numbers. The domain goes from -3 to +3. That's where the domain goes in the y values. That's where the domain goes in the x values. So as an inequality, we could say -3 less than or equal to x less than or equal to 3. And then if we look at the y values, it goes from -2 all the way up to +2. And so when they're separate points, you list out every point. But when it's continuous like this, like all connected, then we have to say it's the whole thing. Okay, next question. Is it a function? Hopefully, because of the vertical line test, you can just see that automatically. Yes, it's a function because the vertical line would only touch it one time everywhere. The domain is the x values. It goes from +1 all the way up to 3 in the x's. So again, as an inequality, we could say it like this. Our y values, it goes from 2 all the way up to 4. And so we could say it as an inequality this way. Okay, next one. Is this a is it a function? Yes, it is. It does pass the vertical line test. So let me bring my vertical line back. So if I have this vertical line, look, even though it has kind of this bump on it or whatever, it's only touching everywhere one time. It never touches it more than once. So this one is a function. On this one, I actually think I want to talk about the range first. Remember, the range is the y values and the domain is the x values. So do you see these arrows? They're pointing downwards, right? That means it's going to go all the way down to -infinity. So it goes from -infinity and then it comes all the way up. And I'm going to bring back my line here. It goes from -infinity all the way up and then it stops here at 0. Right? It doesn't go any higher than that. So it goes from -infinity all the way up to 0. And what we could say then is, and you know what? On some of these I should have used a y. We're going to talk about that. Is that y is always less than or equal to 0. Look, here's my y is 0, and it's always less than that or maybe equal to it. We should change this. X should be a y, and this should be a y. Because those are the ranges, and range is always y values. Okay, now let's talk about the domain on this one. So going back to these arrows again, they are pointing down, but they're also pointing to the side just a little bit. But if you kept going forever and ever and ever, because it does go forever and ever and ever, it would go forever and ever. And so it's going a little bit out to the left every time. And this one is going a little bit out to the right every time. And so our domain is also, well, actually this one time it doesn't have a stop. It goes from -infinity all the way up to +infinity. So again, if we use this as like our range finder, it's going to go all the way from -infinity all the way over and keep going over to +infinity. And another way to say that sometimes is all real numbers. And we use this kind of like a paragraph symbol, but it's with an R for all real numbers. Okay, last example. Does it pass the vertical line test? No, it does not. If it did, let's talk about the domain. The domain is the x values. It goes from here, from 1 all the way up to positive infinity. Once again, these arrows. So in other words, the domain would be everything greater than or equal to 1. The range, it's just not even a function, so let's just not even go there. Okay, a lot of examples today on domain and range. We will work on this in class the next time.